In this problem, we're going to look at the property, the associative property of multiplication over. So we are going to use two different ways of counting the total number of dashes in this group and to demonstrate the associative property. So first of all, we need to answer what is the associative property. So in the general case, we would like you to use variables, just letters A, B, C, instead of using specific numbers. And here A, B, C, they can represent any number, so it includes infinite many cases in here. And remember the associative property of multiplication. First of all the operations are multiplication. Secondly, we have three numbers we multiply, and then we whether we can multiply and the first two numbers or the last two numbers. And the most important thing here is the order of these three numbers does not change. So A, B, C, A, B, C. What changes is we move the parentheses, not the numbers. And whether we associate B with the A or B with the C. Okay, so next we want to use the two different ways to count the total number of dashes here to explain this associative property. So in this specific case, how do we count the total number of dashes? Of course, we don't want you to count one by one, so we want you to set up like a math equation to count something like this or that. And so what we're going to do is, now we divide them into different groups. So first of all, we could divide them into by rows. This is the first row, second row, third row, and the fourth row. So there are four equal groups, or you can just say four rows. And, well, I guess I did explain here. Each group has three groups. I probably should change the three groups here to sub rows, because you can see that in the first big row we have 1, 2, 3 sub rows. So I'm gonna here rows, but I'm gonna call this sub rows to be specific. And next we can see that so let's label this way. So in each big row we have 1, 2, 3 sub rows, and also in each sub row we have 5 dashes. So if you look at the first row, 5 dashes, and second row 5 dashes, and then third row 5 dashes. So there are well, you can always use groups, but you probably have to be specific on what you mean by what's your group. So we the first time when I say group, I mean those big rows separated using by the red lines here. But the second time when I say groups, I mean each of these rows here. And so the way to count it is, so first of all, we're going to count how many in each big row. And notice that we have three groups, and each group has 5 dashes. So that's total of 3 times 5 in here. So that's a total of 3 times 5. Again, 3 rows, 5 columns. And notice that we have 4 of these. So the second one, it's because it's exactly the same shape as that. So that's also 3 times 5. And this is also 3 times 5. And this is also 3 times 5. So you can see we have a total of this many 3 times 5s. So how many 3 times 5s? We have 4 of them. So we have 4 3 times 5s. And that's, we do 4 times 3 times 5. And of course, if you multiply out, you get 15. But in the expression, we don't want you to multiply out. So we're going to keep it as this. But in the explanation, it might be easier to say, okay, we have 15 here, 15 here, 15 here, 15 here. So that's a total of 4 15s. So it's like 4 times 15. But the reason we want to keep 3 and 5 in there, like how you got 15, and is because we want to be able to use this to demonstrate the associative property. So that's the first way to count the total number of dashes. So now let's get rid of that and try a different way of counting. So it depends on how you separate them. So this time, because I want to demonstrate the associative property, so which means I'm going to shift the parentheses from 3,5 to 4,3 and then times by 5. And so which means I have, if you mark it out, that's 12 groups of 5. And so this time, what we're going to look at is, so we're going to count how many rows we have. But again, we're not going to count 1, 2, 3, 4, 5, 6 like that. So the way we count how many total number of rows is, so we have one group, we still can separate them like this. So we have 4 groups, and then each group has 3 rows, or I call it sub rows. And so now the total number of rows we have 3 rows here, 3 rows here, 3 rows here, 3 rows here. So that's a total number of 4 times 3, this many rows. Okay, so so of course if you label it, you will see 4, 5, 6, 7, 8, 9, 10, 11, 12. So again, we don't want you to count like this, but I labeled it so you can see where 12 comes from. So again, the 12 comes from 1, 3, 2, 3, 4, 3, 3, 3, 4, 3 rows, so which is 4 times 3. So that tells us the total number of rows, 4 times 3 rows. And then notice each row we have, first row we have 5 dashes, and second row we also have 5 dashes, and the third row we have 5 dashes. So you can see each of these rows here, we always have 5 dashes. So the total number of rows is 12 rows times the total how many in each row, that's 5. So 12 times 5. But again, we want you to explain where you got 12. So again, 12 comes from 4 times 3. So this way, this is a different way of counting the total number of dashes. And of course, both ways are correct. Both ways tell us how many dashes are in here, in the drawing, in the picture. So they should be equal to each other, whether it's the first method of counting it or second method of counting it. They must be equal because they both tell us the total number of dashes. And and by looking at this, we can see this is exactly the associative property.